So in this video, we're going to talk about how to solve a little more complicated indefinite integrals using u substitution only. There's a couple tricks we need to know, and we'll talk about those as we get further in the videos. So for this problem, I really do recommend to rewrite this. I always recommend to write it 1 over sine squared of 3x times dx. I like to get the dx off to the side. And we know 1 over sine is cosecant. So this is going to be the integral of cosecant squared of 3x dx. And now we're going to implement our u sub. So we're going to let u equal 3x and du equal 3dx. Now again, notice I don't have a 3 right here, so I'm going to go ahead and multiply both sides by 1/3 to get the dx all by itself. And now I'm going to go ahead and use my u sub to get the integral of cosecant squared of u times 1/3 du. I'm going to get that 1/3 on the outside of the integral and get cosecant squared of u du. The integral of cosecant squared is negative cotangent of u plus c. So this gives us negative 1/3 cotangent of 3x plus c. Alright, moving on to number 37. So in number 37, we're going to look at the integral of sine of 2t plus 1 divided by cosine squared of 2t plus 1 of dt. So right away, this looks like an absolute nightmare. Now normally, I tell you to u sub all of this. But the problem with only u subbing that, it's not going to get rid of the sine or the cosines. So I'm actually going to let u equal cosine of 2t plus 1. So when I take the derivative, I get du is negative sine of 2t plus 1 times 2 dt. This piece right here comes from the chain rule. I don't want the 2 and I don't want the negative, so I'm going to multiply both sides by negative 1/2. And I get sine of 2t plus 1 dt. Notice that right here, I got my u sub. So let's go ahead, plug everything in. And we're going to get that this is the integral of 1 over u squared times negative 1/2 du. So this is equal to negative 1/2 times the integral of u to the negative 2 du. So this is equal to negative 1/2. The integral of u to the negative 2 power is going to be u to the negative 1 divided by 1 plus c. A negative and a negative are going to make a positive, so we're going to get 1/2 times 1 over u plus c. And that's going to give us our final answer, which is 1 over 2 times what we substituted back for u. So 2 times cosine of 2t plus 1 plus c. Now for number 38. This is 6 cosine of t divided by 2 plus sine of t squared dt. So I'm going to let u equal all of this right here. U is equal to 2 plus sine of t. And so du is going to be the derivative of sine of t is cosine of t dt. So now what we're going to do is we're going to take this 6 and get it on the outside of the integral. So you get 6 times the integral of 1 over 2 plus sine of t squared times cosine of t dt. Notice that this is my u sub. I'm good to go. And I get this is equal to 6 times the integral of 1 over u squared du. Here we go. This becomes very similar to a previous problem we've done. So this is 6 times the integral of u to the negative 2 du, which gives me 6 times u to the negative 1 divided by negative 1 plus c, which is 6 times negative 6 times 1 over u plus c. So I get my final answer is negative 6 divided by 2 plus sine of t plus c. Good to go. Now for number 39, we're getting a little trickier with our integrals, becoming a little more complicated, about halfway there. So I'm not sure what my u sub is yet, so I'm going to go ahead and rewrite this as 1 over ln of x times 1 over x dx. And for me, this becomes fairly obvious now because I know the derivative of ln of x is 1 over x. So I get du is equal to 1 over x dx. And so now I'm good to go because there's my derivative, and there it is. Just this piece. So now I get, this is the integral of 1 over u du. And the integral of 1 over u is ln of u plus c. And don't forget that u was ln of x. So this is going to be ln of x plus c. Good to go. Alright, let's talk about number 40. Tangent squared x times secant squared x dx. So this is where the problems start to get a little trickier. You got to start really looking for those u subs. Well, right here, I see a sneaky little tangent. And right here, I see the derivative of tangent. So I'm going to go ahead and let u equal tangent of x. And then du is going to be equal to secant squared of x dx. Nice and easy, all nice and spaced out for me. It's all nice. So we get this is the integral of u squared du. I'm going to integrate that, and I'm going to get u cubed over 3 plus c. So this is equal to 1/3 u cubed plus c. So my final answer is 1/3 tangent of x cubed plus c. Alright, number 41. This is where things start to get interesting. Right off the bat, I see x squared plus 1. I think tangent inverse. But wait! There's something different about this problem. It's this little x guy up here. Somehow he snuck his way into this problem. Let's get him out of here. So, what I'm going to do is I know the derivative of x squared is x, or 2x. So u is going to be equal to x squared plus 1. So du is equal to 2x dx. Now I don't want this 2. So what do? I multiply both sides by 1/2. And would you look at that? There's my u sub. That's what I need. So I'm going to rewrite my integral as the integral of 1 over x squared plus 1 times x dx. This is going to be the integral of 1 over u times 1/2 du. And I'm going to get this is 1/2 times the integral of 1 over u du. And the integral of 1 over u is going to be ln of u plus c. So this is 1/2 of ln, and u was x squared plus 1 plus c, and I'm good to go. Alright, almost last problem. Number 42. We got to go up to number 44. We're almost there. Now, this is where this problem starts to take a very dark turn, because here's x squared plus 25. I'm seeing that tangent inverse. I know it's got to be there. I know this looks like tangent inverse of x. But I'm going to do a little bit of simplifying before we hit that u sub. So this is equal to 40 times the integral of 1 over x squared plus 25 dx. Now before I can make that tangent inverse, I need that to be x squared plus 1. It's got to be the 1 to do the tangent inverse. So this is equal to 40 times the integral of 1 over, I'm going to go ahead and factor out a 25. And that's going to leave me with x squared divided by 25 plus 1 dx. So this is 40 over 25 times the integral of 1 over, this is going to be x over 5, quantity squared plus 1 dx. Now I am ready for that u sub, so let's do it. This is going to be u is equal to x over 5. So du is equal to 1/5 dx. So 5 du is equal to dx by multiplying by 5 on both sides. So now, I can go ahead and write this as 40. I'm going to simplify that a bit. I'm going to divide both by 5. I'm going to get 8 over 5 integral 1 over u squared plus 1 times 5 du. 5's are going to cancel. And I'm going to get this is equal to 8 times the integral of 1 over u squared plus 1 du. Now I'm ready for my tangent inverse of u plus c. Now all we got to do is plug back in that u for x over 5. And we can consider ourselves done with that problem. Alright, 2 more to go. Number 43. Number 43. The integral of dx divided by cotangent of 3x. This one might look nasty, but it's a piece of cake. You take the integral. 1 over cotangent is tangent of 3x dx. Look at that. We're already ready for our u sub. U is equal to 3x. Du is equal to 3 dx. I don't have a 3, so then dx is equal to 1/3 du. So this is the integral of tangent of u times 1/3 du. So this is going to be the integral of, or 1/3 times the integral of tangent of u du. So this is equal to 1/3 times negative ln, absolute value of cosine of u, plus c. So this is negative 1/3 ln, absolute value of cosine of u, plus c. Almost done. One little step now to finish it off. We got to plug in the u back in for the x. So it's 1/3 ln, absolute value cosine 3x. Close the absolute values, plus c. Call it done. Alright, last but not least, number 44. I actually think this one is a little easier than number 43. Whenever I have to deal with the integral of tangent, I don't necessarily like it. But, nonetheless, here we go. Again, I do recommend, whenever dx is in the numerator, to rewrite this as 1 over the square root of 5x plus 8 dx. So now I'm going to let u equals to 5x plus 8. So du is going to be equal to 5 dx. I don't have a 5 dx, so I'm going to go 1/5 du is equal to dx. Good to go. So this is going to be equal to the integral of 1 over the square root of u times 1/5 du. So this is 1/5 times the integral of u to the negative 1/2 du. Now we can integrate. So this is 1/5 times a u to the 1/2 divided by 1/2 plus c. So this is going to be 1/5 times 2 square root of u plus c. Go ahead, this is 2/5. Plug in that, what do we do? 5x plus 8 for u. Put a plus c, call it a day. That's how you integrate using u subs. Done lots of different kinds of problems. You should be able to tackle on whatever you encounter.